So we'll just go over what Joel went over last semester, week 14, his introduction to Android. Except this week, this time we're gonna go over more app interaction and less about the Android OS. But that doesn't mean we're not gonna cover it. So what's a mobile operating system? It's a mobile OS, which is an operating system designed for mobile devices like mobile phones, mobile PDAs, mobile computers, and other handheld devices. And Android itself is a mobile OS, which was developed by Google, and you count there, mobile comes up 9 times in that slide. So if you have an operating system, you have a kernel. Linux systems run on a Linux kernel. Android runs on a modified Linux kernel. Now Androids run apps through ART, which is Android Runtime, which has a lot more improvements over Delta VM. And we'll get to that, but so some common app flaws is that Android can be decompiled back to Java code. Android allows for easy installation of third-party applications. Any custom encryption methods that can be written in code can be extracted, and that applications can request more permissions than they actually need. Another thing is ADB. I'm sure Joel also went over this, but here are some of the commands that you may need for this week's demo. ADB logcat is kind of like syslog for Android. ADB shell will give you a shell on your device. ADB devices will give you a list of devices. And ADB pull is how you copy files over to your Android device. So let's dive a little deeper.
So to kind of cover some background technologies a little bit, if you haven't heard XML, it's kind of, well, it's the extensible markup language. So when we did other web stuff, and you saw HTML, right? You saw these opening and closing tags and things, right? That's an XML-based language. So you have these opening and closing tags. These tags can have different attributes, and then they also have different values that are between the tags. If you see over here, like this is the opening tag, this is the closing tag, pretty simple stuff. This is normally for like program-to-program communication. It allows for easy just taking data, putting it in a file, transferring it over, having another program parse it out and use it. When you get to bigger files, it's really not that readable for people, but it's better for computers to pull it apart and look at it. So just like pretty much everything, any software project has like sort of vulnerabilities. So if we go back to like what we did with HTML and other things that are involving web, you see that we have the potential like ability for injection, right? So if you can take advantage of the program that is creating this XML file, you can potentially put something in it, right? You can put a tag in there that isn't supposed to be in there. Maybe it does some function for it, or maybe it just clutters up the data, right? So some applications of this are like making an XML bomb, right? Making a file that might be 200 kilobytes and then making it expand in memory to over 2 gigabytes, right? So making this small file size explode into a larger one, like a bomb. We're going to go over that in a little bit. We're also going to go over XXE, which is External Entity Processing. In XML, you have the ability to load external entities or other files, whether it be another XML file, or whether it be a text file, or something else, right? From an attacker's point of view, we can leverage this for like file system enumeration. We can say, okay, well, give me Etsy password. I want to see the users in the system, or I want to see these other files, or whatever. So let's say you upload an XML file to a website, and you give it an tell it to load an external entity. You can then enumerate files that are on that web server. So kind of to go over like the XML bomb, we create this entity A and then have it respond to like A. So every time you load this A, right, it's going to go to here and say this is 50,000 A's. Every time this loads, it's going to go back to this and fill that in there. So you've said essentially creating a variable, right? A is equivalent to 50,000 A's. And then you want it to reference that like 50,000 times so that you can make it blow up, right? Trying to cause some sort of crash in the application that's parsing this XML document so that you can take advantage of that or cause some sort of denial of service. So XXE loading this external entity. You see over here we have this XML document. And we create the doc type of foo, and we tell it that foo can pretty much be anything, right? So when we load this entity, it says we're going to go and reference out XXE, right? So we go out and we find where that is, and we see that is a system entity, right? And that it's the file etsy password. So by doing this, we can read files in the system, and if whatever server or program that's parsing this is not configured properly or proper operating system controls are not put in place, we could be able to potentially read files from there. Cool. So if you haven't heard of JSON, it's the JavaScript object notation, right? It's a way to easily encode data from one program and get it to another. It kind of fulfills the same role as XML. XML and JSON kind of compete in the same space for usage. JSON has been used a lot more recently and is a lot more human readable. It's designed or it was originally designed so that you could transfer information about JavaScript objects from a web server to a browser so that a browser could efficiently do all of the object-oriented programming that it needed to do on the client side. So it's set up kind of like how you would think like a class and an object would be in programming. You can create a class and then it can have different types of attributes. So it can have a string, it can have a number, it can have an array, it can have a sub-entity, right, or like a child thing. And if we look right here, it's set up kind of with this syntax. Like there's curly braces everywhere, and then there's different attribute names. So if you think about this kind of like you're programming, well, we create a string that's called first name, and then it has a value of John. Last name is a string, and it has a value of John, right? And then this right here is an integer. So it's a way to easily take this information and put it in a format that both humans can read and computers can parse and work with.
So we're going to talk about APIs. Use the link. So you guys might have all heard of APIs. It's a word that's thrown around a lot. Essentially, it lets you interact with the application outside the application itself. So the way it does that is that an API is a set of routines and protocols and just tools for building your software application. A lot of famous apps like Twitter, like Facebook, they all have public APIs that you can build off of. So it's kind of like a software library or a software framework. There are some differences, but essentially it's all about that usability. APIs are a little bit more abstract than a software library or framework. And there are many types of APIs, but since we're doing web, we're going to go into web APIs. And so the REST API, it stands for Representational State Transfer. It uses the HTTP get, post, put, and delete requests. And it was introduced by Roy Fielding, who designed HTTP 1.1. And it follows 6 constraints. The first one is that it's the client server, so it's a separate client and server. So the client and server have separate security concerns and just like software concerns. So that way you have portability and scalability because you have one server and then you can have multiple clients. The next thing is stateless, which is essentially when the client is the transition between states that's going through individual requests, and that benefits security. The next one is that you cache responses, and you cache responses because it's a lot faster to take static information from a cache server than to constantly load it from the origin server, and that helps scalability and performance. The next one is a layered system, so that way, the client doesn't ever really know if their device is connected to the origin server or intermediary server. So because of that, you take advantage of that, and you set up a bunch of intermediary servers. So you can distribute the load. So that's scalability and load balancing. The next one is uniform interface. This is kind of optional, but it's good to include. But it's having the same interface between the server and the client, and that gives you design standards. So that's important. So how do you not get POEM when you use a REST API?
So you can do something to proxy requests, and you can screen them before they get there, right? So if you're doing this from an attacker standpoint, you can set up a proxy on your machine, and you can, let's say, test an application. right? So you want to test whatever web app you're doing, you set up a proxy that's going from your browser or the Android app that you're using that will intercept all of the HTTP requests that are going out to that API. It's very similar to what you're doing in programming, right? When you create a function and you use a function, often you pass arguments to it so that it's used as a variable. Well, it's the same kind of thing with an API. You're passing either post parameters or get parameters so that they can be used on the server to get you some information. You can fiddle with those different parameters. You can put in values that aren't expected, and you can do this because you're intercepting the traffic before it gets to the target destination. You can also do this on the return, looking at it still from the application side if you want to mess with that, so that you can alter data that should be coming from the server to something that isn't, so that the application might wig out or show you a graphical area that is not available if you're not an administrator, that kind of thing. And checks are being done on the client side so that the client can be tricked into letting you have more privileges than you actually have. From the defensive side, as of looking at web requests and like how do I defend these servers that are holding up this API, you put a proxy in front of those, right? You set your proxy up so that it looks in and it screens all the requests that are coming in and says, this looks kind of wrong. Like if somebody's GPS data suddenly jumped from Somalia to like Japan in the matter of like 500 milliseconds, that's a little wacky. Someone's probably spoofing their GPS, right? And if you're using an app like Tinder or Facebook or whatever, odds are they're going to be in the same place and they're not going to be able to jump like a hemisphere like in a split second, right? So it's screening these things that are coming in so that you can say this is a bad request and I'm going to deny this request, or change whatever values are in this request to be something that's more normalized so that you can inspect and detect attacks that are coming at you. Yeah, so looking from the client side, like attacking point of view, if you wanted to download Burp Suite, Fiddler, or Tamper Data, Burp Suite and Fiddler, those are two of the more common standalone applications. They're very feature rich. If you want to learn more about Burp, shoot me a message. I lived in it last summer. There's a lot of there's a lot of different things that it can do, a lot of different tools that are built into Burp that help automate the process. Fiddler is an open source, I believe, application that does the same kind of thing. And then Tamper Data is a Firefox extension that allows you to intercept requests coming straight from your browser. And if you want more information on how to use Burp, go back and see week 10 of fall 2016, or just shoot me a message.
So, if you guys were here last week, we talked about the Facebook hack, and that was insecure an insecure direct object reference. So that's number 4 on the OWASP top 10, and that's when a developer exposes something like a unique identifier in the URL. And so you see at the bottom right there, that's an example where that's an insecure direct object reference, because we can transfer money from one account to the other with just a URL. So how do you stop this? Well, you never, ever, ever let the access control key. You never, ever let an HTTP post request have an access control key that gives you automatic verification. So let's see. So Facebook, for example, has a unique identifier at the end of the URL. Just because you log into that and you can do like a /message doesn't mean it'll let you post, because that URL doesn't give you automatic verification. You still have to do a data contextual check, I think that's what it's called, on the server side every time you make a request like that. And so other ways to, I guess, stop other security flaws is input validation. That's when you validate response types. So you validate the JSON, the XML, and you do secure parsing on the XML, so you don't have XXE and you don't have XML bombing. And do you want to talk more on this?
Yeah.
Okay.
So input validation is pretty much what Sean said, is inspecting what you're getting. So if we look back to the classic, you have a web page and you're trying to make someone post a comment, right? You don't want them to be able to put a script tag in, right? So you want to have filters that are designed that will tear out these script tags, or just straight up deny something that says there are illegal characters in your message. Input validation is making sure that everything fits in what you're expecting. So normally there's two steps. There's normalization and then there's validation. So you use the normalization to filter everything, and then after everything has been met, you've stripped out all those bad characters, you then want to run it through a validation engine that is going to say, okay, now that this is in a language that I understand, does it look right? And if it looks right, you're going to let it through. In the event that you're able to bypass the sanitization and validation part, you have to worry about how you're encoding data, right? So if you decided that you were going to skip the input sanitization and validation altogether and you were just going to post things to your website, one thing that could easily be done is HTML coding of in characters, right? So for the simple attack of getting a script tag to run through a comment, if you HTML encode everything from just a very naive perspective, you can change all of those opening and closing brackets to not be opening and closing brackets, but actually be the ampersand LT for less than and ampersand GT for greater than, so it doesn't show up as a character that your browser will interpret as an HTML tag. It'll just interpret it as text. So for output encoding, you can do a lot of different things with this. There's many different ways to do it. It's not just HTML encoding on the outside. There's different applications that you use for JSON and XML, and you really want to use the standard libraries for this. People have already solved this problem. Don't go reinventing the wheel. Use the standard libraries for input sanitization, validation, and output encoding, unless you have some specific thing for your application that you need to do.
Yeah, there are a lot of application frameworks that have solved a lot of these problems, so stick with them. But now let's dive a little deeper. Let's get into reversing Android apps. So those are just some of the tools you could possibly use. So that's APK tools, Smalley, Dextojar, JetX. We'll go over them in a second. That's spelled wrong, but one of the questions you can ask is, or I guess a workflow is, do you want to decompile it or disassemble it? Those sound like similar things, but are slightly different. Decompilation is when you convert the software binaries into this clear text format, which is still in that high-level language, which is very, if not the same as the source code that the developers have written. So that way you can actually read it. Disassembly is is a one-to-one translation from bytes to text. So when you do that, it's still readable, but it's not as easy as it's just reading the source code. But before we get into reverse engineering, how do you even make an Android app? So first, developers write their source code in Java. Then the Java files get compiled into a Java class file. Then use the DX tool, which comes with your Android software developers kit, SDK, software developer kit. It's one of the Android build tools. And then those DEX files get packaged with the other resources you use to make that APK package, which is your app. So to reverse it, you reverse it. You turn that DEX into a jar with Dextojar. You decompile that jar with JADX or JDGUI. And then you look at the code. Or you can use an Android decompiler, DAD for short. DAD is short for a Dalvik decompiler, so instead of going through this entire process, DAD will do everything for you. So the only thing is that there aren't a lot of DADs out on the internet. This is Android Guard's DAD is an open source DAD, and one of the benefits of using a DAD is that we transform DEX to jar. When you transform a DEX into a jar, you could possibly lose some important metadata. So you can use an Android decompiler, which will save some of that.
You're a terrible person for using that picture.
Anyway, so this is something cool that I found. It's Santoku Linux. We won't be using that, but if you want to look into it, by all means, it's kind of like a tiny Kali, but for mobile forensics and mobile malware development and all that stuff. So it's really cool. I'll let you know when I look more into it. But yeah, there are a bunch of tools that come with it, and some of them you will actually use today. So here's some other resources and sources, and if you're interested in this, Joel is probably the best person to hit up. He helped a lot with making this week's demo. So if you have any questions or things you want to do, you'll ask him. Questions?
Just gotta refresh the presentation.
Me?
Add a slide.
Oh yeah, this slide. This one or the welcome slide?
Yeah. Perfect.
Woo.
So, alright. So, real quick, we have for your demo today, you're going to be connecting to one of our remote servers. I'm just going to remind you all that that top one is the one that you're going to be connecting to. So, if any of you want to touch it, that's the one that you touch. Anything that's in red, don't touch. Don't poke it. Don't do anything like that, okay? If I see it, we're going to have a conversation. And it's not going to be a good conversation because you're going to have to prove to me what you were doing. So don't do that. So clearly labeled, it's even on a different port, okay? So that's what I'm trying to say. It's very easy. It's in green, so don't touch the other ones. So pretty much CLDR, you guys know what you're doing. So if you need help, you feel like you're doing something wrong, come talk to me. I'm okay with that conversation. So, cool. Anyone got any questions about this? Sweet. That's what I like to hear. Let's go do demo.
Woohoo.
Adam punishment that if you fuck up, basically slack like this impersonates you. I was thinking that last time I was like, Vegas instead of throwing it. Yeah, I know. You're saying that, I was like,